Hello everyone, it's Wilson here. Today let's talk about solving absolute value equations with one absolute value. Before we start solving the equation, we'll recall one idea over here first, is that we have absolute value of a number, and that if that is equal to a positive number, then that tells us that it would be the distance between that number and 0. So graphically, we can see that on the number line, there is a 0 here, and that number, there would be two possible spots for that number. It's really because we just need to have that same distance away from 0, so it can be on the right side of the 0, and it can also be on the left side of the 0. Okay, so now coming back to this equation, it tells us that this 3 is the distance between this number, the 2x minus 1 is an expression, and 0. Okay, so that means we have two possible spots for this 2x minus 1. What really happens is that if you just want to see it graphically, okay, so 0 is right here, and then 2x minus 1 should be 3 units away from 0. So 1 is that 2x minus 1 is over here, and then it's at 3. And then the other side, it's on the left side, right? We have negative 3 because it's also 3 units away from 0, and then 2x minus 1 can be on this side. So that means what? That means 2x minus 1 can be equal to 3. Or the other one is what? The other one is when 2x minus 1 is equal to negative 3. So 2x minus 1 is equal to negative 3. So we have those two possible cases right here. And now if we solve each of those equations, then we can find the x value that will satisfy the equation. Now let's solve this one really easy. So we can add 1 to both sides of the equation. Then we are going to get 2x is equal to negative 3. Those will get cancelled. So negative 3 plus 1 will get negative 2. So x is equal to negative 1. So that's one possible answer. And the other one is when we do the same thing here. So we add 1. Then this time we have a 3, so we are going to get 2x is equal to 4. So x is equal to 2. Okay, so those two would be the solutions. And you can actually just plug them back into the equation and then show that it will satisfy the equation. Okay, so now let's do another example. Okay, so now we have just seen the example using the idea over here. We have another example over here. So we're going to use the same idea over here. So we can draw the graph, but actually eventually when you become better, you may not even need to draw this, right? You can see this in your head. So what happened is that we have this expression that's inside the absolute value, so that is our triangle. And then what happens is that the distance that the negative 2x is away from 0 is 8 units. So that means we have 8 over here, and then we have negative 2x, and the other one is going to be negative 8, and then we have negative 2x. Okay, so now we have two equations. We have one of them is negative 2x is equal to negative 8, or the other one is what? Negative 2x is equal to 8. Now solving each equation, we have one of them is giving us 4. The other one, we have negative 4. And so those would be our final answers. Now let's see another example. Okay, let's see another example. Here's our third example. Absolute value of x plus 4 is equal to 0. Okay, and we're still going to use the same idea here, but this time the example, we have a 0 on the other side. So it will be a little bit different. Why is it different? It's really because now the distance, it's going to be what? Between x plus 4 and 0 is 0. So how do we represent this if we are actually just writing this? Now the distance is 0, so that means x plus 4 is not away from 0. So that means what? That means x plus 4 must be at this spot only. Okay? And so we don't have two cases anymore for the x plus 4 to be equal to that number, whatever number it should be. It will only give us one case. And so what happens is that we have just x plus 4 is equal to 0. And so that's it. So we solve this equation, and we are going to get negative 4. That would be our final answer. Okay, let's see another example. Okay, now here's the fourth example, and the difference between this example and the previous three examples is that the absolute value is not isolated. And so one important idea to get started for solving this kind of equation is that we need to first isolate the absolute value. So that means we don't want this positive 4 on the left side of the equation. We want to get rid of that so that we have the absolute value of x plus 3 on the left side only, okay? So now that means we got to subtract 4 from both sides. And so we are going to get absolute value x plus 3 is equal to 2 minus 4 is what? Negative 2. And this one is also different from the previous three examples. It's really because if you look at the number over here, it's not a positive number. It's not 0 either. It's a negative number. And then you may say, what's the problem with negative number? And just recall from before is that the absolute value gives us the distance that this number inside the absolute value is away from the 0. Now it says that the distance is what? It's negative 2, but we cannot have negative distance, right? So that means we actually don't get any solution for this equation. So we have no solutions. It's really because this is this number here is a negative number and the absolute value is equal to that negative number, right? So, okay, so distance can't be negative. And then you can also think of it the other way as that when we find the absolute value of something, then we are going to get either a positive number or it can also be 0, but it cannot be a negative number. So there is no value for x that will make it to work. And then you may say, what if I follow whatever that I was trying before? I set it equal to positive 2, negative 2. We can try that over here, but this is wrong, okay? So don't do this. Is that we are going to just force it, and then we say x plus 3 is equal to 2, and the other one is what? X plus 3 is equal to negative 2, and then we try to solve it that way. And then what happens is that we are going to get x equals negative 1, and then x is equal to minus 3, we get negative 5. And then you may say, okay, so are we getting two solutions? But if we put those back into the original equation, it doesn't work. Because let's say we try to plug it back, this x equals negative 1 into the original equation. Then the left-hand side is going to give us what? We have the negative 1, okay? And then we have plus 3 and then plus 4. And then we do the calculation over here, then we are going to get absolute value of 2 plus 4, which is equal to 2 plus 4, and then we are going to get 6. What about the right-hand side? The right-hand side is actually just equal to 2, as you can see. So it doesn't work. And I'm not going to show this. This will actually give us something similar, so that also will fail to work. Okay, so this equation has no solution, so that's our answer here. We can box it. Now let's see our last example. Okay, last example. This time we are going to solve a more complicated one compared to all 4 examples that we were seeing earlier. Okay, so now first, as you can see that the absolute value is not isolated, and so the first thing is that we need to isolate the absolute value. We're not going to use this idea yet until we have the absolute value isolated. Okay, so the first thing is that we are going to get rid of 5 on this side of the equation. So that means we are going to subtract 5 from both sides. Okay, and then those two will get cancelled. So we are going to get negative, so keep the negative sign, and then we are going to get 3x plus 2 inside the absolute value, and then we are going to get what? 4 minus 5, so we get negative 1. Now you can see that we have a negative number here, which is similar to the previous example, but also we have a negative sign in front of the absolute value. So we still don't consider that we have the absolute value isolated. We still need to get rid of this negative 1 in front of the absolute value. And then you may say, what should we do? We can divide both sides by negative 1. Okay. And then so negative 1 divided by negative 1 will get positive 1, so they cancel out. So we are going to get just the absolute value on the left side. And what about this? We are going to get 1 on the right side. Now, see that this is a positive number, so we're going to use this idea now. The distance that 3x plus 2 is away from 0 is equal to 1. So in that case, if we draw the lumber line over here, so let's just quickly draw the lumber line. So we get the 0 here, and then it's just 1 unit away from the 0. And what is that? That's 3x plus 2. And then we can also have 3x plus 2 on the left side of 0, and it's also 1 unit away from 0. So that means we have 3x plus 2 is equal to -1, or the other one is what? 3x plus 2 is equal to +1. So now we just need to solve those two equations. Here we are going to subtract the 2 from both sides. And so we are going to get 3x is equal to -1 minus -2, so we get -3. So x is equal to -1. As you can see, the 3 times -1 is -3. And the other one is what? The other one is going to be, well, similar idea over here, so -2 from both sides. So we are going to get 3x is equal to 1 minus 2, so we get -1. So x is equal to, divide both sides by 3, so we get -1 over 3. Okay, so you can see that we still have 2 solutions over here. And that's it for this equation. Okay, so you have seen 5 examples. We're going to do more examples on solving absolute value equations next time. Thank you for watching.